Good day everyone. Today my friend and I will be presenting on techniques of differentiation for subject MAT183. We are from AS12040. I hope by the end of this presentation you will gain a better understanding of this topic. So without further ado, let's begin. So here is a picture of our group members who work together to complete this assignment. Firstly, we will begin with question 1, introduction. So I'll be explaining the meaning of differentiation and what are the techniques of differentiation. Differentiation is the process of finding the derivative of a function. The derivative measures how a function changes as its input changes. It represents the rate of change or slope of the function at any given point. So, fx is written as first derivative or dy over dx. This is the list of techniques of differentiation. So, to start, we have the constant rule and power rule. The first rule we will look at is the constant rule in differentiation. This rule says that the derivative of a constant is 0. In simple terms, if a function is just a number, like fx equal to 5, then its derivative is 0, because the value never changes and there's no slope. For example here, y is equal to 2, meaning that dy over dx is equal to 0. There is no x term, no curve, no changes, and it's just a flat horizontal line, so the rate of the changes is 0. You can think of it like walking on a perfectly flat road with no incline. Your height never changes, and so is the slope as 0. Next, we have the power rule, one of the most commonly used rules in differentiation. It is used when you are differentiating term with x raised to a power. So, as we can see here, y is equal to 3x with the power of 4, meaning that dy over dx is equal to 3 with 4x with the power of 3 is equal to 12x with the power of 3. In other words, you bring the power down in front, then subtract 1 from the exponent. You can remember it as power down, then minus 1. Now let's look at the generalized power rule and exponential function. Let's look at the generalized power rule first. This rule is used when we have a function raised to a power. So as we can see here, y is equal to x squared plus x with the power of 5. The power of 5 is brought to the front so that dy over dx can be equal to 5x squared plus x with the power of 4, adding with 2x plus 1. After that, it will be equal to 5x squared plus x with the power of 4 and 2x plus 1. Plus, you still can bring the power down and subtract 1 from the exponent, but you also have to multiply by the derivative of the inside function. This is like a mini version of the chain rule. This rule is especially helpful when you're dealing with bracket raised to powers. Next is the derivative of exponential functions. For the basic exponential function, fx is equal to e, and the derivative is first derivative and is equal to e with the power of x. It is unique because it's the only function that have its own derivative. So, for the explanation, we can see here, y is equal to e with the power of x squared minus x. So, dy over dx is equal to e with the power of x squared minus x with a bracket of 2x minus 1 close the bracket, and e it is equals to close bracket 2x minus 1 close the bracket e with the power of x squared plus x. And just remember, when differentiating exponential, don't forget to multiply by the derivative of the power if it is more than just an x. Next, let's talk about product rule and quotient rule. Firstly, we will start with product rule. We use this when differentiating two functions that are being multiplied. So, as we can see here, product rule means that y is equal to x squared plus sine x with the power of 3, meaning that dy over dx will be equal to 2x plus cos x with the power of 3 and add with 3x squared. For you to understand more, there's a formula that you can refer. First, I'll explain it the way we can understand it better. So y is equal to fx multiply with gx. So x, we will replace it as u, and for the g part, we will replace the x with equal to v. So the multiply is a product rule. So dy over dx will be a new formula, which is vu prime plus uv prime. In simple words, differentiate the first and keep the second. Then keep the first, differentiate the second, and add both. For you to be more understand, here's a tip. Always label your function as u and v first. It helps to organize your work. Write the formula before plugging in values to avoid mistake, and don't forget to add the plus sign is a sum and is not a difference. So, next we have the quotient rule. We use it when we want to divide two functions. For this one, I want you to understand that the formula for these both is quite similar but not that similar. Firstly, like I showed here, y is equals to x plus 1 over x minus 4. So, the y will be e to the power of x over sine x. So, y is equal to ln x plus 1 over x plus 3 with the power of 4, and y is equal to cos x minus 6 over x minus 2. It is shown here that the over is what we call quotient rule. So, for the formula, we have dy over dx is equal to vu prime minus uv prime over v2. Or we can use dy over dx is equal to 1 over v2 and put it in the bracket, vu prime minus uv prime, and close the bracket. You can either use the left one and the right one. up to your preference. If you like it, if you like the left one better, you can use it so you can understand it and make the answer for your question more simple for you to understand. Last but not least, guys, we have trigonometric function and logarithmic rule. Firstly, we will take a look at trigo function. These are very common in calculus problem, so here are the most important ones to remember. So here, I already give you guys the table so that you can refer to it and make no silly mistake, because this one is so easy if you understand it better. So for A until D, you guys can see that the sine, cos, tangent, and cotangent is when equal to dy over dx, it changes. So you have to remember it well so that you will not make any mistake. For example, A, y is equal to sine fx, so it will be dy over dx is equal to cos fx with the first derivative of x. So for E, it will be a little bit different, but worry not, because you just have to add the tangent and you will be fine. So y is equal to c fx, so it will be dy over dx is equal to fx multiplied with tangent fx with the first derivative of x. It is the same goes for the f. So you can see here, it is what the formula is given, so you can understand it better. So let's move on to the logarithmic rule. Oh, before I forget, this is a tip for you guys to remember how to do trigo function. You will need to always be careful with sine, especially with cos, which become negative. And you have to use the chain rule if the angle is more than this and x. And you have to memorize this table because they are used a lot in question or in the text. So let's look at the logarithmic rule. The derivative of the natural logarithm function is what we can see here. So y is equal to 1 bracket for x with the power of 4 minus 1 and close bracket. So the result will be dy over dx is equal to 1 over 4x with the power of 4 minus 1. So to understand it better, you must label like this. So 1 is 1 and the 4x with the power of 4 minus 1 is 2. So for the result, it will be easy for you to do it like this. It will become 1 over 4x with the power of 4 minus 1. So the number 2, it will be 16x with the power of 3 minus 0. Why does the 0 is here when in the question it is minus 1? You need to understand it is because the minus 1 is the constant. So when it's constant, it will be 0. So the final result, it will be equals to 16x with the power of 3 over 4x with the power of 4 minus 1. So for this tip, I would like to recommend you to always simplify where it is possible. And always make sure the argument of the log is positive. Logarithmic differentiation is useful when dealing with complicated products, power, or quotient. So I hope you guys can understand it better for this technique of differentiation.
Hi, my name is Arnisa, and today I would like to do a question 2a and 2b. For the question 2a, we need to find dy over dx for the following function: y equal to 4x plus tan square sin x plus 3. First, we differentiate the 4x, which is simple, d over dx 4x equal to 4. Next, we look at the second part, tan square sin x plus 3. Here, we let u equal to sin x plus 3. When we differentiate tan square u, we use the chain rule, d over dx tan square u, 2 tan are equal to 2 tan u secant square u du over dx. For step 2, now we find du over dx. Since u equal to sin x plus 3, du over dx is cos x plus 3. And the final step is we put it all together, dy over dx equal to 4 plus 2 tan bracket sin bracket x plus 3 secant square bracket sin x plus 3 cos bracket x plus 3. In short, we differentiate each part one by one. First the 4x, then the tan square using the chain rule, and don't forget to multiply by the derivative of the inside function sin x plus 3. Next, I would like to go to the second question, which is find dy over dx for the following function of y equal to exponent 2x minus 2x over 3x plus 1. We are given the function and we want to differentiate this using the quotient rule. Step 1. Since this is a fraction, we use the quotient rule, which is y prime equal to vu prime minus uv prime over v square. We let u equal to exponent 3x minus 2x and v 3x plus 1. Now we differentiate both. U prime equal to 3 exponent 3x minus 2 and v prime equal to 3. And next, for the step 2, now we substitute into the quotient rule formula. And next, we expand and simplify. And finally, after simplifying, we get the 6x exponent 3x minus exponent 3x minus 2 over bracket 3x plus 1 bracket square. The summary for the question is we applied the quotient rule where we took u as the numerator and v as the denominator. We found u prime and v prime, substitute into the formula, expanded the terms, and simplified the expression at the end. That's all from me. Thank you.
Assalamualaikum, my name is Dani Sahana and I will be answering question number 3. Given 2y over x plus 5 exponent 5x ln cos y equal to 5x cubed plus 2. Find dy dx using implicit differentiation. Firstly, we have to divide this question into 3 parts and solve it one by one. First one, 2y over x, we simplify it become 2y times 1 over x, and 1 over x we need to bring the x to the top and become x power negative 1. And then we use power rule, we find u equal to 2y, v equal to x power negative 1, and u prime, we differentiate 2y and got 2 dy dx, and v prime we got negative x power negative 2, and then put it in the formula vu prime plus uv prime. So for the first one we got 2 over x dy dx minus 2y over x square. Second one, 5 exponent 5x ln cos y, using power rule we assume u equal to 5 exponent 5x, v equal to ln cos y, differentiate u we got u prime 25 exponent 5x, differentiate v we got v prime equal to 1 over cos negative sin y dy dx. Put it in the formula product rule vu prime plus uv prime, we got 25 exponent 5x cos y plus 5 exponent 5x tangent y dy dx. Number 3, using power rule 5x cubed plus 2, we differentiate 5x cubed, we got 15x square, differentiate 2 we got 0. And then we put all together the answer from the previous one and we divide the question that contain dy over dx to the left side and the rest on the right side. So we got the answer dy over dx equal to 15x squared plus 2y over x squared minus 25 exponent 5x ln cos y over 2 over x minus 5 exponent 5x tangent y.
So let me continue for the next question, which is question 4. The question is use linear approximation to estimate the value of 80.99 square root with 4 minus with 2 over 80.99 square root. So for the first step, you need to find the value of x1 and also x0. So x1 equals to 80.99 and x0 equals to 81. It is because you just take from the 80.99 because the 0.99 is more than 5. So you just take as 81. So the next step is find the value of fx. So fx equals to x power with 1 over 4 minus with 2x power with negative 1 over 2. And the third step is find the dx. So for dx is x1 minus with x0. This is the value you can get from the step 1. So 80.99 minus with 81 and the answer you get is negative 0.01. For the fourth step is you need to find the f prime x. So f prime x equals to 1 over 4x power with negative 3 over 4 plus with x power with negative 3 over 2. So for the next step is f prime x0 equals to 1 over 4 and in this bracket x0 is from the number given in the step 1, so you just replace with 81. So 1 over 4 in bracket 81 power with negative 3 over 4 plus with 81 power with negative 3 over 2 and the answer you get is 31 over 2916. So the next step is find the value of f x0 equals to f 81. Like usual, you need to replace the x0 from the number given. So equals to 81 power with 1 over 4 minus with 2 over 81 power with 1 over 2 and the answer is 25 over 9. In the sixth step, you need to find the changes. So the equation for find the changes is df equals to f prime x0 dx. So you just replace from the formula, which is 31 over 2916. Then replace the dx amount, which is negative 0.01. So you will get the answer is negative 31 over 291,600. And the last step, you need to find the new value. The new value equation is f x1 equals to f x0 plus with df. So you just replace the number from the step 5 and also 6. So 25 over 9 plus with negative 31 over 291,600. And the last answer is 2.778, correct to 3 decimal places. Thank you.
So for the conclusion, overall, this project enhanced our problem by solving abilities and emphasized the relevance of differential calculus in academic. We already explore fundamental concept and technique in MAT183 and focusing in their practical application through step-by-step problem solving.